Hello students, this is another video on conic section. In this video we will discuss about hyperbola. Okay, now what is a hyperbola? A hyperbola is the set of points in a plane. Now what are those points? The difference of whose distance from two fixed points, that is we are talking about focus, two fixed point in the plane is constant. In the plane is constant. Okay. Now one thing that you should remember in the case of hyperbola, that in this case we don't have major or minor axis, we have transverse axis and we have conjugate axis. Okay, these 2 points are called focus, these are vertex, and this is called center. Okay, now let us see some results. To find that P1 F2 and P1 F1 is constant. Now what is a P? This is not P1, actually P. Taking the point P at A and B, so this is my A and this is my B. So we take A and B. So BF1 minus BF2 is equal to AF2 minus AF1. That should be constant by the definition. So here BF1, see this part, okay. Here BF1 is nothing but AB plus AF1, okay, is equal to AB plus BF2 minus AF1 is same for A2, okay. The AF2 can be written like this. So from here I can write this implies AF1 equal to BF2, cancelling all the parts, so that BF1 minus BF2 is equal to BA plus AF1 minus BF2 is equal to BA. Now what is this? From here I can see this BA is nothing but twice A. Okay, we consider this length as twice A. It means that PF2 minus PF1 is equal to twice A, the length of transverse axis. So this is a constant quantity. Okay. Now let us see what is the standard equation of hyperbola. You remember the diagram, okay. Let F1 and F2 be the foci and O be the midpoint of F1 F2. Let O be the origin and the line through F2 be the positive x-axis. Okay, so transverse axis is x-axis for standard equation of parabola, and the same line through F1 as the negative x-axis. Okay, the line through O and perpendicular to x-axis is y-axis. So in this case the we consider y-axis as the conjugate axis, or conjugate axis as our y-axis, so that we can define the coordinates. Okay, once the coordinate axes are defined, so let OF1 equal to OF2 equal to C, this constant distance, then coordinate of F1 and F2 are minus C comma 0 and C comma 0. Okay, this is clear respectively. Let Pxy be any point on the hyperbola such that difference of the distance from P to the further point minus the closer point, that is we are talking about focus. Okay, so this is the point, this is your transverse axis, this is your conjugate axis. So this is P and this is your F1 and this is your F2, suppose. Okay, so difference between further minus closer is constant. Now what is the constant? We have already calculated that constant is the transverse length of transverse axis, that is twice A. Okay, it means Pf1 minus Pf2 is equal to twice A. Okay, using the distance formula we have this one. Okay, we know this coordinate, we know this coordinate, so we can find the distance. Similarly in the case of Pf1, so we have used the distance formula, taking this quantity in this side, we got this, squaring both sides and simplifying, we got this result, again squaring, we got this equation. Okay, now this quantity, this one, we name it as b square. So the equation we got is x square by a square minus y square by b square equal to 1. Okay, so one thing, foci is always on the transverse axis, that you have to remember, and it is the positive term whose denominator gives the transverse axis. It means suppose x square by a square minus y square by b square equal to 1, then here the positive term is x, so the a gives the transverse axis. Okay, So twice a gives the length of the transverse axis, and a represent the length of semi-transverse axis. So, but if I write like this, y square by b square minus x square by a square equal to 1, then the positive term is y square. So the transverse axis is along y. Okay, so this hyperbola will look like this, and the focus is on this. Now this cannot be a conjugate axis. This is again transverse axis. Okay, this is transverse and this is the conjugate axis in that case. So conjugate transverse axis is always always represents by the positive term, and the denominator gives the value of square root of the denominator gives the value of length of semi transverse axis. Clear? Now comes to lattice rectum. Now lattice rectum of hyperbola is a line segment perpendicular to the transverse axis through any of the foci and whose endpoints lie on the hyperbola. So this is the length of lattice rectum. So like ellipse only, the length of the lattice rectum is same in this case. That is why I have not proved this part. So you can see this part in NCERT book, or you can simply calculate this part also. So with that I am closing this video. In the next video we will discuss about problems related to ellipse and hyperbola. So that will be end. Tomorrow I will upload videos on problems on ellipse and hyperbola. So till then, thank you so much. Bye.